Greetings everyone. Today we are going to learn about the refraction through a prism. So basically we are going to see what will happen if the light passes through a prism. Clear? But in this case we are not going to take the white light, but instead we are going to consider one monochromatic light. Okay? So let us draw prism first and then we will see what will happen over here. So this is the triangular prism. Let us call it as the ABC. Let us draw a ray incident on the side AB. So let it be the incident light PQ or incident ray PQ, which is making an angle of I about the normal. So in order to draw the normal, let us take this incident point and let us draw a normal to it. So it will be like this. Now this is our angle of incidence. Now as we know that for this monochromatic light, that is the light with the single wavelength, it is passing through the prism. That means it is going from the one medium to the another medium. Let us say this is the air and prism is obviously made up from the glass, so this is the glass. So it is moving from the rarer optical medium to the denser optical medium. That means the light or the beam should move towards the normal. So this beam will move or should bend towards the normal. That means instead of going in this direction, it will bend towards the normal. Suppose this is the bending of the light. And it bends at the angle of the refraction. Let us call it as the R1. So this is nothing but the refraction angle R1. Now as you can see that this light, let us consider this beam as the beam QR. Let it be QR. I'm not going to write it down right now, but I am keeping the symbol around here. Okay, then we need to draw something a little bit of here. So after that I am going to move the notation. So this is the refracted ray QR. Now as you can see that it has been incidenting on this side AC. So again it will make some angle of incidence and again it will get refracted. So in order to figure out the angle of incidence, we need to again draw a normal to the side AC, and that can be done by choosing the point of incidence, and let us draw a normal to it. So let us consider this as the normal, and we need to extend these normals, normal of this side AB and normal of this side AC, so that we can get the intersection point over here. Okay, so this is the another normal, so this become another angle of incidence. Now I am, for the sake of simplicity, I am going to consider this angle of incidence as the R2. Now you might be wondering that why R2 instead of the I1 and I2. That will be clarified after the completion of the topic. But this is the angle R2. It is nothing but the angle of incidence for the phase or for the side AC. Right? Now, from the optically denser medium to the optical rarer medium, our beam travels. So it will move away from the normal. Okay, denser to rarer, it will move away. So this is the normal, it will move away. So it will be like this. Okay, now let us keep this point as the R, and this is the emergent ray RS, and it will make the refraction angle, also known as the angle of emergent or emergent angle, E. Clear? Because it has been basically refracted twice and it is refracting in the same medium as the original. Clear? So it is nothing but the emergence ray, and this is the emergent angle. Done. Now the very special case. What will happen if I remove this prism? Okay. Now make sure that I haven't told that what will happen if I remove this prism and if I turn off this light. But I am just removing the prism. So let us consider that this light will continue this path, its original path. Suppose there were no prism. Okay. If it is confusing, then let me use the red marker. So if there is no prism, then our light will follow the straight path. As we know that light always moves in a straight line, right? Similarly, let us put the prism over here. Let us put the light source over here. Okay, let us assume that light source is at the edge and the angle of incidence is exactly equals to the angle of emergence for this case. So if our I is equals to E, then the same phenomena will be repeated. That means the same sort of refraction and the emergence will occur in the prism. If our E is equals to I, that means this will be I, this will be R1, this will be R2, and this I will be E. So basically we have just reversed the direction of the incident ray. In that case, again we are going to remove the prism. So suppose our light source is over here and we are removing the prism, so it will follow its original path. Now I have stopped over here because we just want to get the intersection point, this. Clear? Now this is the angle. Here this is making the angle delta. Delta is known as the angle of deviation. Angle of deviation can be defined as the angle between the incident ray and the emergent ray is known as the angle of deviation, denoted by the delta. Now let us give the name to these points. This be the M and this be the N. Now this is the complete diagram that is given in the NCERT. Now study the diagram thoroughly, and then we are going to proceed towards the derivation of the equation. Now this question can be asked as the refraction through a prism, or it can be asked as the prove the relation between the angle of incidence, angle of emergence, and the prism angle A, as well as the angle of deviation delta. Or it can be asked as the prove that or show that delta is equal to I plus E minus A, or delta plus A is equals to I plus E. So there are number of ways that the question can be asked in the examination, but you need to study thoroughly and perfectly, so that means you won't get confused in the examination part. So that is it. Study the diagram, draw the diagram, and then we are going to continue towards the theory and the derivation part. Okay, now we can see one thing over here. We are getting a quadrilateral over here, A, Q, and R. I am drawing it separately over here, A, Q, and R. Here you can see one thing. That means this one. The angle Q is nothing but the normal on the side AB. So that means that this angle will be right angle. Similarly, on the right hand side, R is nothing but the normal on the side AC. That means R will also be the right angle. Okay, that means angle Q and angle R in quadrilateral A, Q and R will be of 90 degree. So that means that angle A and angle N will make up of total 180 degree. So this can be written as angle A. This is also known as the prism angle. Okay, prism angle A plus angle Q and R. This one. Is equals to 180 degrees. Correct? If you don't get this equation, then that is nothing but it is the summation of all the angles of the quadrilateral. That we know that summation of all the angles of the quadrilateral will always be the 360 degree. So it is nothing but the angle A plus angle Q plus angle N plus angle R is equal to 360 degree. Now we know that Q and R, this and this is 90. So angle A plus 90 plus N plus 90 is equal to 360. This will sum up 180, and when if we move this 180 to the other side, then 360 minus 180 will give us nothing but the 180. So that is the direct equation that we have written over here, and let it be the equation number 1. Okay, so first of all, in the diagram we have considered one quadrilateral. Now we are going to consider another shape, which is the triangle Q and R. So from the triangle Q and R, again we know that the sum of the all angles in the triangle will be 180 degrees. So in the triangle Q and R, angle Q, that is nothing but our R1, plus angle N, or let us say it is Q and R, plus angle R is equal to 180 degree, right? So this Q and R we do have in this triangle, it is nothing but the R1, and this R is nothing but the R2. So R1 plus Q and R plus R2 is equal to 180 degree. Now let it be the equation number 2. Now let us compare equation 1 and 2, as we have on the both sides 180 degrees. Either you can understand by this, or you can do one thing such as that you can make the Q and R as a subject, and then you can substitute the value over here. Okay, whichever you find convenient, you can follow the maths. I am simply going to compare this equation 1 and equation 2. So from the equation 1 and 2, we will get angle A plus Q and R is equals to 180 degree. That 180 degree will be this side, R1 plus Q and R plus R2. Okay, this is the angle Q and R. So this angle Q and R will get cancelled, and ultimately we will have nothing but the A is equals to R1 plus R2. That means I can also rewrite this as the R1 plus R2 is equals to A. Let this be the equation number 3. Is it clear, everyone? Now the main part is coming right now. So note this down, and then we are going to proceed to the another triangle, and that will be our end of the first part. Okay, now for the third part, we are going to consider this triangle MQR, for which we are going to find out what is the angle of deviation. Okay, for which I am going to assume this angle as the X and this angle as the Y. If you cannot see this triangle, then let me draw it over here. Okay, this is M Q R, in which I have drawn these two angles. I have represented these two angles, or I have assumed these two angles as the X and Y. Now we are getting one line over here. You might get the geometry that where I am exactly heading. Okay, this is nothing but the angle of deviation. If you compare this diagram with this one, then this is nothing but the a bit enlarged version of this one, if you are getting a bit confused over here. Now, as we know from the geometry of this diagram that this is the exterior angle. Exterior angle delta is equals to the interior angles x and y that you might have learned in your lower standards. So from the diagram, delta is equals to x plus y, but we don't have exactly what is the x and what is the y. So we first need to figure out what is the value of x and what is the value of y. So you can see one thing over here. If you see closely, if you observe it properly, then we are getting the x over here. Okay, this x over here, it is I, and this is divided into the two angles x and r1. So this x is nothing but the opposite angles. Clear? Okay. So from the opposite angle, we know that this I is equals to the summation of these two angles. So let it be I is equals to x plus r1. Right? This is the x, this is the r1. The summation of x plus r1 will be equals to the I. But we don't have the x over here. Okay? Let us consider this as the equation number A. By subtracting the x, we are getting x is equals to I minus r1. Let it be equation number B. Similarly, we are getting another cross over here. Clear? This red line and this normal of this side AC, like this. So this is the angle of emergence. For this, it has been divided into the two angles. The one that we have assumed as the y, and another one that is the R2. Now you can also do one mathematical trick over here. Okay, it is not the trick, it is the thorough mathematics. You can consider this y as the 90 minus R2 angle, because this is nothing but the right angle. Clear? But instead of that, we are just going to consider the x and y. Now, this E is equals to the y plus r2. Okay, now I need y, so y is equals to the E minus r2. Let it be the equation number C. Now substitute the value of equation B and C in equation A. We will get delta is equals to the value of x from equation B and value of y from equation C, I minus r1 plus E minus r2. Let us open the brackets and it will be I minus r1 plus E plus minus minus r2. Now I am keeping I plus E together, and let us keep r1 minus r2 together so that we can bring the minus sign common. So delta is equals to I plus E minus r1 plus r2. Because we are keeping the negative sign common, so it will convert it into the plus. So this is the I plus E minus r1 plus r2. Now if you can recall the equation number 3, which has been written over here for the sake of the reference, and you can also check in your book that you have noted from the video, that r1 plus r2 is nothing but the A. That means that delta is equals to the I plus E minus A. That is our ultimate equation. And here the part 1 of this question completed. Okay, and let this be the equation number 4. Now not up to here, and if you have any doubts, then you can comment down in the comment box. Okay, now we know that the angle of deviation is depends upon the angle of incidence. This plot is being given over here. Now as you can see that as we gradually increase the angle of incidence, our angle of deviation decreases at some point. After that, but it again increases, right? And we can see another thing over here that for any given point I, suppose this one, we are getting the one delta here, and for that delta we are getting another I over here. This is the fact that in the prism we have encountered this one thing, that this diagram can be traced back. That means what? Either we can go from this side, okay, from left to right, or you can also go from right to left. Okay, this proves that one, that for the any single angle of deviation we are getting the two different angle of incidence, that can be either I or E. Now you should note that here E is the angle of emergence, which is equals to the angle of incidence, but in this case this E will become our I, and in this case it is already I. So this is the interchangeable terms. Clear? Now we want to define what is the minimum angle of deviation. For that we are going to consider this point. At this point you can see our I becomes E prime. That means for this single angle of incidence we are getting the deviation, and as you can see this is the dip over here. So this will be our minimum angle of deviation, that can be denoted via dm. For minimum angle of deviation, our condition is that I should be E. Clear? This I should be E. That means we are getting only single angle of incidence, and that we are getting over here as the dip. If our I is E, then depending upon the I, we are getting R over here, and this I is equal to this E. So over here we are also getting the R. That means for the given angle of incidence, the angle of refraction will remain same. Now by that means R1 will be equals to R2, and that is, let us consider this R1 is equals to R2 is equals to R. Clear? Now let us substitute these values to the previous equations. So from R1 plus R2 is equals to A. Let us substitute this value R over here. So it will become R plus R equals to A. That is 2R is equals to A. Now if I want to have the R, let me make the subject R. Then R will be A by 2. Let it be equation number 5. Similarly, let us consider this equation 4, and let us rewrite it as the minimum angle of the deviation. So instead of the delta, we are going to consider it as the minimum angle of deviation. Okay, this can be represented by capital D subscript M. So from equation 4, our delta will be equals to the dm. Now dm is equals to, let us substitute this condition over here, I plus I minus A. Therefore dm is equals to 2I minus A. Now I want this I, right? I want the angle of incidence. So let me make I as the subject. So 2I will remain over here, A will come over here. So this minus A will be converted into the plus A. Minus A to this side is plus A. Therefore our I will be this 2 is in the multiplication with the I, so if I change the side, then it will be in the division of this term, dm plus a by 2. Let it be equation number 6. Is it clear, everyone? Now we know that in this case, or in the case of the topic, we are considering nothing but the refraction. So for the refraction, we are going to apply the Snell's law, right? Okay, let us apply the Snell's law. So from the Snell's law, as we know, Snell's law is nothing but the n2 by n1 is equals to n21 is equals to sine I by sine R. Now we are getting one thing over here, I and R, that we have already figured out in equation number 5 and 6 respectively. Now let us substitute this value of the I and R in this Snell's law and let us rewrite it on the other side. Now let us substitute the value of I and R in this equation. We will get n21 is equals to sine, the value of I is equals to dm plus a by 2. So it will be dm plus a by 2 divided by sine R, the value of R is equals to a by 2. Now this dm and a can be calculated or can be measured experimentally from the prism. Now let us consider for this very thin prism, our a will be smaller. Now as we have discussed that if a is smaller, then our angle of deviation will be also the smaller. So now for the smaller angles, we can consider sin theta as roughly equals to the theta. So for thin prism, sin theta is roughly equals to theta. That means n21 is equals to dm plus a by 2 divided by a by 2. Now this is the denominator of the numerator, that will be our denominator, and this is the denominator of the denominator, that will be numerator. In the simple words, it will come downwards and it will go upwards. Or we can do one simple thing, just cancel out this one. So we will get over here dm plus a by a. Now these are our simplification steps, so you can skip those steps and we can directly write down the result over here. I am going to give the separate denominator over here, so it will be dm upon a plus a by a, dm by a plus a by a. So as we know, a by a will get cancelled and we will get n21 is equals to dm by a plus 1. Now here we are interested to figure out the minimum angle of the deviation instead of the refractive index of the medium. The medium is the prism. So let us make this as the subject, and in order to make it subject, let us first move the 1 from the right hand side to left hand side. So it will be n21 minus 1 equals to dm by a, and if I move a from the right hand side to the left hand side, then our equation will be obtained. So let me write it down over here. Therefore dm is equals to a into 1 minus 1. This is the ultimate formula for the minimum angle of deviation by the prism in the case of the refraction. So this is it. If you have any doubts, comment me down below, and that is it. Thank you.